Hello, everyone, and welcome to today's webinar hosted by Manhattan Associates. I'm Matt De Muynck with Manhattan's marketing team, and we're glad that you're joining us as we delve into the transformative power of unifying planning and execution. Our speakers today, Brian Kinsella, Senior Vice President of Product Management at Manhattan, and renowned logistics analyst Bart De Muynck, will share their insights on how this integration can revolutionize your supply chain. We encourage you to submit your questions throughout the webinar using the Q&A function within the application. We'll dedicate time toward the end of this presentation to address as many as possible and follow up with a post-event communication to address any that we didn't get to cover. Now today, the presentation is going to address an industry perspective on unified business planning, as well as Manhattan supply chain planning, and then the unifying technology based on the Manhattan Active Platform. So without further ado, I'd like to go ahead and turn it on over to Bart De Muynck. Bart?
Thank you, Matt, and welcome everyone to today's webinar. My name is Bart De Muynck. I'm an independent advisor and thought leader with over 30 years of experience in supply chain. And I've stood in the same role, in the same shoes as many of you when I worked at PepsiCo, where I spent 10 years in logistics. Probably I talked to a lot of you during my 8 years as VP of Research at Gartner, where I led the transportation technology research. And more recently, I worked closely together with some of you as a Manhattan partner as an executive at Project 44. Now, today we'll be talking about unified business planning. I'll give you an industry perspective of the challenges that supply chains face and the need to unify supply chain functions and the associated technologies. And so what I'll be doing in the first section is to talk to you about some of the challenges that we've historically seen in the separation between supply chain planning and execution. Then I'm going to give you a couple of real examples, the ones that I lived through in my 30 years in the industry. And those challenges were inhibiting people to have more collaboration between the areas of supply chain planning and execution. And then finally, I'll talk about supply chains of the future, what we need to do and how we can accomplish it. So let's dive right into it. To kick off this part of the webinar, I want to provide an industry perspective on the need for unified business planning and even more unified supply chain platforms. We've heard a lot about the external disruptions that supply chains have been facing these past few years, caused by COVID, by geopolitical and socioeconomic events, as well as weather events. But there are many more intrinsic challenges, call them even disconnects within the traditional supply chain. So I'm going to walk you through some of those major challenges. The first challenges that we've seen in supply chains is that between the different supply chain systems and functions, we've observed this difference in horizons from a time horizon perspective. So in fact, supply chains have different time and planning horizons. And we could classify those as strategic, tactical, and execution. Now, supply chain planning works at a very strategic level, but is not dynamic, as in reacting to real-time events and outcomes. And execution, on the other hand, is at the other side of the spectrum and is often not strategic or even tactical in nature. We forget to plan, forecast, and model logistics, and rather just execute based on orders that we receive from upstream systems. And the two sides are very disconnected. I would say that even at Gartner, we were often challenged when between the analysts, we were talking about the two parts, and it was a tough subject because I was on logistics. So people always said, well, Bart, you're logistics. You're just execution, right? What would you do on the planning side or the tactical side? But also the supply chain folks really looked at supply chain planning from a pure tactical and strategic perspective without really understanding the value that the execution could bring to the planning team. Now, the next challenge is that traditional supply chains are very linear. And everyone's probably familiar with the SCORE model, where we plan, then we execute the plan by procuring the goods and manufacturing the products with either raw materials, components, and semi-finished goods, or in some cases, we just distribute the finished goods. And then we take them through the pick, pack, and ship, where we take products from the warehouse, and finally, we deliver them to the customer. And in some cases, we even organize an entire return system as well. And that's kind of how we've traditionally looked at a linear supply chain, where we chronologically execute all of those steps one at a time. But I would say that in today's fast-moving, disruptive, and much more global supply chains with ever more demanding customers, that approach really no longer works. And if it works, it really is slow, it's very costly, it takes a lot of resources, and it doesn't offer a competitive advantage. Now, the third challenge we've been seeing is around the fact that we have supply chain functional silos. Now, let's just take a minute and really look at supply chain as a term, because when you look at like the Webster Dictionary, you can see that the definition of a chain is a collection of rings or links that are tightly connected. So a good example of a chain would be a bicycle chain, right? I think all of us ride bicycles. Now, what happens with a bicycle chain if one of those links break? Well, there's not going to be any power that is being transferred from the pedals to the wheels to have forward motion. And that's the same in supply chains. But in reality, we still see a lot of disconnects within that supply chain. So I would even go so far to say that in most organizations, that the different functions are really siloed. And I've personally seen that. I continue to see it even today, where the different organizations don't communicate, and there's very little collaboration between the silos. And that really has caused a lot of issues within those supply chains. In a recent survey, it showed that the biggest disconnect in supply chains is actually between supply chain planning and logistics. And with all the technology we're using today, including communication tools like Slack, we sometimes forget the art of human-to-human communication. So in many cases, we don't even know what our colleagues need in order to have their function work very well, or how to use more data or more capabilities across their function. And that brings us to another topic, which is the topic of data, which is also very highly disconnected. Now, in the past 10 years, we've seen an explosion in technology. We've experienced the IoT revolution, and that caused us to have a lot more data. Today, we have something like 200 times more data than we've had 10 to 12 years ago. Now, I would say 30 plus years when I started in supply chain, we didn't have enough data. We had applications, but we didn't have data. And I could say that today we almost have too much data, more than we know what to do with. But the problem is that the data is very much segmented in different pockets. And that even those companies who have been able to holistically bring all that data together in some type of repository don't always have the ability to link the data through a single technology platform. And that prohibits them to really use the data, to drive it into insights and really drive decisions. And also because of that, they lack the ability to truly drive the execution of these decisions through the application. So that really brings us to a couple of examples that I've experienced over the last 20 to 30 years in some of those disconnects and the challenges that it brought to the different organizations. So these are examples from companies I worked at, that I partner with, or that I currently advise. And some of these might sound very familiar to you, and I'm sure all of you can come up with many, many more similar stories. So let's start with the first one. So the first one was when I was working at a large CPG manufacturer. I would say that as a logistics organization, we were extremely advanced, and I would say we were considered experts in transportation. But we also realized that in order to get more productivity out of transportation, we needed to get more visibility from the upstream planning systems, as orders were hitting transportation with very little lead time. And at the time, the supply chain planning systems and the TMS, our transportation management system, were completely disconnected. And the data from the supply chain planning could be very beneficial to create truckload orders in that TMS. So we started to look how we could solve the challenge. And we were lucky that the business case was big enough to try and make the decision to try and figure it out. So we ended up building something, but it took us over 2 years, and it was a huge investment. It was a highly complex solution if you look at its architecture. And I'm going to talk about how many millions of dollars it cost us to build something in the ERP system that was able to connect upstream to planning and downstream to the TMS. But we finally got something that somewhat worked. Now imagine having those systems that talk to each other, that share the data with each other, then you wouldn't have to go through all those challenges. Unified systems would actually save time. They would save a lot of investment, and it would also help you to create the value a lot faster. Now, the second example is from a distributor that had inefficient labor planning, both in manufacturing and in warehousing, because they were disconnected from the supply chain planning process. Now, the data was available in the organization, but the functions weren't connected. So the data wasn't able to be shared between those functions, and that really resulted in inefficiencies in how the labor was scheduled in both manufacturing as well as at the warehouse. Now, the warehouse often doesn't get full access to what, for example, demand planning already knows. So let's say there's a spike in demand, something that's hitting a lot of the inbound or outbound movements from a warehouse. The warehouse isn't always aware of that in time. And so we can't always schedule the labor accordingly. Now, this is even more important today when we see shortages of labor, as we see the aging of the working population, especially in the labor in the warehouse, where not only do we have difficulty in finding labor, but also where we see fairly low retention rates of the labor with high attrition. Now, my last example stems from a retail company that I work with while at Project 44. This company really needed the transportation data from the execution team to create better supply chain planning, and that was all based around lead times. And so when we sat together with both of the teams, the planning team and the transportation team, we quickly realized that the planning team could really use the information that the execution team, the transportation team, had through means of visibility and other solutions. But the planning team wasn't aware that transportation had that data. And so when we asked, or when they asked the transportation team if they had that data, they said yes. But the transportation team was fully unaware that supply chain planning could actually do something useful with their data. So again, a missed opportunity of sharing the data between two different applications, but again, it led to certain inefficiencies in that supply chain. So now let's talk a little bit about the future supply chains and what they need. And so the story is that future supply chains will need to operate very differently if they want to be and remain competitive. And again, we live in a much different world today where supply chains are a lot more global. Changes happen a lot faster, and disruptions continue to hit us and will continue to hit us from all different angles. So Gartner created a really good view of this a couple of years ago. So at the core, it basically focuses on the fact that supply chains of the future need to be circular rather than linear, where companies use real-time data at any point to create and execute real-time decisions. So to be really, in essence, a lot more dynamic and agile. And so what that means is that you need to have those different functions collaborate. And you need to have the data that is stitched together to kind of cross those different functions. But you also at the same time need a different way of working, something that's very human-centric. Now, if you keep doing the same old thing, looking at linear supply chains with functional silos, even with the best technology, you're not going to be able to be competitive in the environment that we are facing today. Because today's environment is so complex with supplies that are much more global. And at the same time, the world continues to change. And at the same time, customers and consumers are much more demanding. Now, next, we also need to enable and align the supply chain functions a lot better and kind of destroy those silos by true collaboration. The same study that I mentioned earlier shows that those companies that have aligned supply chains with teams from planning, sourcing, manufacturing, and transportation that all collaborate, they tend to be not just more balanced, they have the smallest alignment gaps, but also those companies that have the closest alignment didn't just improve their employee retention, but they also drove growth faster than their peers, and they were outperforming their peers in both operating margins and inventory terms. So it shows that it's very important to collaborate and align, and it's not just something that in theory is going very well and makes sense, but it's something that gives companies, I would say, quantifiable benefits. Now, the next part is really to connect the data across the supply chain, right? Where we're talking about a true value creation or a value pyramid of the data. So companies need to connect that data where they can drive planning data down to the level of execution and understand how they can execute these plans very efficiently. But at the same time, you don't want to use the data just at the execution level. Rather, you want to use the data further upstream to plan transportation more efficiently, to connect transportation execution data to the warehouse and to the yard, to have a better overall logistics plan, and finally, to use the execution data in the supply chain planning process to more accurately forecast and plan. This is where data can be used across the multiple time horizons and create exponential value for organization. It's what Manhattan calls unified visibility. So there really needs to be a bidirectional interaction of the data that then supports bidirectional collaboration. And by the way, at the same time, a lot of that data can be used across the supply chain around things like traceability, which is very important, for example, if you're a food manufacturer or retailer. But it's also important from a sustainability perspective, where we continue to see more and more regulations around the world. Now, technology alone will not fix things. So really modern supply chains need a different way of working, because new technology platforms can drive business transformation. But no, you might be thinking AI is going to automatically do this. It's not going to happen, okay? It's still going to be all reliant on humans. But they're going to use AI to do it better and more efficient. Now, you should really look at AI as augmented intelligence that supports the human, making them better, helping them to have better professional lives, which also enhance talent attraction and retention. It will enable a different way of working. It will allow companies to bring these disconnected timelines closer together. And that's really going to help in closing those gaps and creating truly connected functional processes and break down those functional silos. That's really where this unified supply chain platform come in to offer the ability to connect data and integrate technologies, strengthened by a really powerful partner ecosystem. And why is this possible now? Well, it's not something we were able to do 30 years, 20 years, even 10 years ago, because the technology wasn't available. But as we move from application stacks to technology platforms that are built on microservices architecture, that now allows us to adopt solutions a lot quicker and create value connections, which also help them to expand solutions. And you got to remember, we're not just doing that within a single application or a single vendor, but we're enriching the platform with a whole ecosystem of data and solution provider partners. Now, Matt, that concludes my section from an industry perspective.
Okay, well, that's great. Thanks, Bart. I really appreciate it. I do actually have a few follow-up questions for you. Hopefully I can frame them properly. But one, on the first one, which was the manufacturing example, not getting visibility to the order for TMS planning until kind of too late. Mm-hmm. The follow-up question is, why did you guys decide that was an interesting problem to solve? I mean, you said it wasn't easy or cheap one, but what was the value unlock, the value unlock in having better collaboration between the planners and the transportation department?
Yeah, it's a great question, Matt. Now, what we realized, and we also saw an evolution, that orders were coming in later and later. So it really gave transportation a lot less lead times, which obviously impacts the opportunity to optimize your transportation. But if we were able to get data from these planning systems that were working, several weeks ahead, and we were able to get full truckload orders from the planning system, let's say 2 or 3 weeks ahead, it really allowed us to build more continuous trips. And I would say that's really where across the common carriers we had, the private fleet and the dedicated fleet, we were able to build those trips and creating a lot more value. At the same time, we were creating a lot of value as well for the carriers because we were able to give them a lot better trips, which really allowed them to use their fleets more efficiently. And I would say lastly, it's something that's definitely more top of mind today, is as we're optimizing these trips as well, we're using the fleets more efficiently. It's obviously also more sustainability, which is, again, something that companies now are looking for.
Okay, that's fantastic. Then the second question is on the sporting goods scenario. So the sporting goods retailer scenario, you mentioned that the visibility data, which was highly useful for the transportation operation on an ongoing basis. So the planner said, all right, so I have that data, and could we have it? Why were they interested, and why was it helpful to these guys?
Yeah, unfortunately, a lot of planning system, things like lead times are often still very static data points that the planning folks put in manually in the system. But now, a lot of companies have real-time data to their, have that available. But also, I would say they're using things like visibility platforms. So they're knowing in real time and even predictively how much a lead time will happen. And so when things are changing, and not just in COVID, but even today when we're seeing conflicts happen like in the Red Sea, or we're seeing things happen in the Panama Canal, and all of a sudden you see these huge fluctuations, and maybe something from China going to the US taking 3 weeks, and now all of a sudden it takes 5 weeks. But alternatively, when the issue is resolved, it goes from 5 weeks, maybe back to 4 and 3 weeks. It's very important that you use that real-time information in planning. Because if we're planning for new inventory replenishment and we're using old data, let's say the lead time has increased, now we're not going to get the inventory in time and we could lose revenue. But also what we've seen is a lot of issues around too much inventory and inventory carrying costs. So if we're not using the right lead time and now we're generating too much inventory, that's increasing obviously the cost on the supply chain side as well, which in turn impacts their cash flow. So having those real lead times that are being fed from other systems on the execution side up to the planning systems have huge impact on overall inventory and how to use that inventory in a much more efficient way.
Perfect. All right, great. That's well said. Thank you. And Bart, thanks so much for the industry perspective. We're going to go ahead and we're going to move on over to Brian Kinsella, where he can go ahead and give us some insight into Manhattan Active Supply Chain Planning.
Terrific. Well, thank you, Matt, and welcome everyone. I'm very happy to be here with you today. I thought Bart's introduction was fantastic, and I think really laid out some interesting scenarios around the opportunity to unify planning with execution, and how it's really, I think, the next step in evolution as we think about supply chain technology and how we can get further unlocked. So without further ado, why don't we delve straight in and take a look at some examples. So what I'm going to cover today is really two pieces. Most of my time is going to be spent on those scenarios and how Manhattan Active Supply Chain Planning, which is our really brand new, completely redesigned and rebuilt supply chain planning application built on the Manhattan Active architecture, can do some interesting things that we, frankly, ourselves couldn't do in the past, even though we've had planning and execution technology under the same roof for a number of years now. And that's because of the unifying technology. So I'm not going to get into a lot of bits and bytes here, but just conceptually, what does an API first or microservice-based architecture afford us the opportunity to do, and why? I want to touch on that a little bit for today's discussion. So without further ado, why don't we delve back into these scenarios that Bart covered earlier, and starting with his first one, which was built around this notion of a CPG manufacturer and that connectivity between inventory requirements coming from a forecasting and inventory planning engine and a transportation planning or optimization process. and what we think we can do a little bit differently here by bringing these two pieces together. So let's start with status quo. So admittedly, these are going to be some basic examples because we want to move through a few different flavors of things, and we got to keep it basic to make these points. So a couple of examples here of really 4 suppliers, each of with whom we have an inventory need. So essentially, we're buying these fixed goods into our network as a CPG manufacturer, or moving really any goods into the network for any purpose. But the planning process is essentially telling us, okay, we have this fixed quantity need from supplier 1 and supplier 2. And in this example, essentially, we're taking that as discrete requirements, non-fungible, non-changeable inventory requirements that are coming into the network. And then essentially we're pairing supplier 3 and 4 together on a separate route. So not bad when you look at the overall truckload utilization. So of course, this is a 2-stop pickup and delivery into the network, both of which, probably running in excess of 90% cube utilization or weight utilization there. And I think, part of what's at play here is this idea of essentially a fixed direction, one-way street of supply chain planning saying, I need this much inventory on these dates, and TMS responding to that. So it's sort of the proverbial pig through the python as this inventory moves through the network. And there's really no collaboration here, as is depicted by this very simple diagram. Essentially, supply chain planning is saying, go move this quantity of inventory into the network on these dates. Essentially, no negotiation. We feel like there's an opportunity, though, as we start to do some of this collaboration between the two, to improve on the results here. So I mentioned, the utilization was good, but we all know that truckload is paid for in miles driven. And so the question becomes, how might we actually reduce the miles driven and reduce our freight spend without negatively impacting or materially negatively impacting inventory availability into the network? The answer to that question comes from this notion of further segmentation of the demand. So we talked about those fixed POs in a minute ago, but that's really not the best way to think about it. The best way to think about it is, how much of that quantity do I absolutely have to have on that date? And how much of it is fungible, is debatable, is something that we could potentially get in a subsequent shipment without necessarily impacting our service levels to our customers or to our manufacturing processes. So in this example, we start by segmenting this demand into the must replenish need, and you can see those quantities are quite a bit less, approximately half or so of that overall original PO quantity. Once we have that segmentation, we then invoke Manhattan Active Transportation Management to say, okay, now how might this route be put together, knowing that that's really the quantity of inventory that has to move that is non-negotiable, that can't be changed. And what we see here is, again, basic example, but I think illustrates the point pretty well. We have the ability to drive a different route on the multi-stop pickup and actually reduce the miles driven to 475. So we're still moving goods from suppliers 1, 2, 3, and 4. However, we're pairing them differently to drive fewer miles into the network. Now, you might say, well, 23,000 pound shipments is not terribly good use of that trailer space, which would be true. So we don't stop there. Essentially, we also add in a certain amount of elective replenishment needs. So remember that we had that overall quantity at the beginning of inventory that was on that original PO. We take a segment of that inventory to essentially top off those routes based on the inventory that we need. So again, by breaking the inventory need into these constituent components, must and elective, we actually get a different problem to solve for the transportation planning engine. A different inbound route is put together, and then we go back to the Manhattan Active Supply Chain Planning engine and say, okay, now tell me what's the best way to use the remaining space on these trailers with that stratified demand. Okay, so that's our first example, and that comes from the world, as Bart described, more from the world of CPG, really moving that supply into the network and how to think about time phasing differently in order to drive fewer miles and still satisfy the need. Now let's turn a little bit more toward a manufacturing scenario that focuses on inefficient labor planning. And we know that labor can be a really large part of supply chain expense, and the ability to really avoid those situations where you're spending a lot of additional unplanned labor because of unforeseen or spiky inventory needs is one of the things that we can focus on. So like we talked about before, pig through the python, supply chain planning says, here it comes. Do with it the best you can. You do not have the ability to feed us back any information about how things could be made a lot easier / more efficient and more cost effective. So with this collaboration, we're going to be able to change that. So up here, what you're seeing essentially is a picture of this unified business planning console. And what I would draw your attention to, again, is it's not just telling us about inventory needs in the form of inventory, which is also letting us know about transportation as well, as you can kind of see from that dashboard there. So where are we going to be light and where are we going to be heavy in terms of transportation? The same thing holds true with labor, telling us where we're going to need more labor in those out weeks and months and quarters helps us get ahead of that plan as well. So simply providing that visibility helps us really right size our labor needs and not have to be in reactive mode with things like unplanned overtime or unplanned temp labor or those types of things. So getting that visibility to discrete movement of inventory by essentially a rolling 52-week horizon really helps the operation plan much more effectively in advance for what they're doing. But we don't stop there. We want to go a little bit further. So essentially, knowing that from a supply chain planning standpoint, we've got to move inventory in. And of course, a supply chain planning process in isolation in one of the silos that Bart talked about earlier, it's essentially going to say, bring me the inventory as late as you possibly can, such that I'm not impacting service level. Why? Well, because that's the lower inventory carrying cost outcome optimization. The problem with that, of course, though, is back to that labor example. That's really not factoring what is that going to do to my operation. It's going to wreak some havoc on the transportation side for sure, but it's also going to wreak a lot of havoc on the labor side as well. So the question then becomes, how might we look at smoothing this out, right? So in this example, we essentially have a period over the course of the next 23 weeks where we are underutilizing the labor pool that's there based on the projected inbound inventory that we have to check in through the gate, put in the yard, bring into a dock door, and go through the receiving and put away process. Of course, there's an associated set of labor required for each one of the weeks based on that projected inventory. And we know right now, or what the system's telling us, in fact, is you've got too much. And so you can do one of two things. You can either not have those individuals come in, especially in the near term, that can be pretty difficult. Or there's perhaps another answer, which is we can actually go back and forth between the applications and smooth this out. So we actually, in that prior example there, I'm going to go back one slide actually and show it. You can see in weeks 15, 16, through 18, we were under capacity or really didn't have enough labor in order to meet the needs of the inventory that was coming in. What does that mean? Well, we all know the consequences here. The trailers sit on the yard longer, the inventory isn't available. We may perhaps have some detention or demurrage charges from a transportation standpoint. A lot of times we do flex up the inventory in very costly ways in the form of, again, overtime or temp labor to be able to do that. But we think there's an opportunity to solve this in a more holistic way, really by breaking down some of those silos. And so in this case, what we do is we actually bring in the inventory a bit earlier. And that might sound a little bit counterintuitive because, of course, it does drive up the inventory carrying cost. However, when you look at the labor cost that was saved by doing so, because we didn't have all of that unplanned labor expense hit us at the last minute, we actually have a lower total landed cost for this scenario in terms of bringing the inventory in for the upcoming season. And I think that's an important concept, driving to this lower total landed cost, because as we think again about breaking down those silos, we've got to come up with these metrics that encapsulate how supply chain is performing for the business, not just how it's performing in the aspect of transportation or in the aspect of inventory carrying cost or service level, but how is it performing for the business overall? So new KPIs and measuring things really on a broader, more unified basis is a key part of this. And then the next step, of course, is how do we optimize for those new KPIs that really encapsulate everything that's happening from an operational standpoint across the planning and the execution domains. Okay, finally, let's move it along to the last area, and that's the sporting goods retailer example that Bart talked through a few minutes ago. So we're going to go in a little different direction here, but conceptually, hopefully you kind of see these things knitting themselves together in terms of planning and execution, or operations really collaborating. Again, our favorite diagram here, supply chain planning. This time, really not getting any upstream visibility to any sort of disruptions that happen in the environment. So again, we've talked about this one-way street, right? Planning says, go do this. And if all hell breaks loose downstream, it doesn't know. And because it doesn't know, it can't really help. If it knows, it can actually make some interesting choices in terms of more intelligent ways for the operation to respond. And so let's look at an example like that. Okay, very basic ship to retail scenario here. Any of those of you guys who have been in that environment understand. Essentially, you're bringing in orders mostly at the beginning of the day, and then you are essentially putting those onto routes and then waiving them throughout the course of the day to get those put onto shipments and sent off. Not all stores are worked on at the same time. You have a set of shipments that go, or a couple sets really that go in the morning, some more sets that go midday, and some more sets that go into the afternoon, and really another set that typically would go later in the evening. And the question then becomes, what happens when things don't go according to plan from an operational standpoint? In this example, we've got some distribution orders that came down and were fulfilled, and we are keeping pace. We were able to fulfill them all. We were able to get the shipments turned and off the dock. Everything is leaving on time. But now, we had some inbound shipments delayed. They were supposed to cross dock so that they could fulfill some of the shipments later in the day, meaning the orders were dependent on that. Now, without that inventory, what would happen? Well, the inventory wouldn't be available. And so I would essentially then not have full trailers and really not maximizing the miles driven, nor the labor in the DC for that matter, in terms of getting the store the best possible shipment. Instead, now what happens is supply chain planning will actually rebuild those orders based on the fact that one set of inventory was missing. So it will say, what else do those stores need? How can I fill up this trailer? Stuff that I will probably ship it, a day or 2 or 3 days later. I'm going to actually front that a little bit to fill out those trailers, knowing that we're going to kind of do a flip flop. And tomorrow, that inbound shipment that was delayed will be the inventory that goes a little bit later. Otherwise, what's going to happen? Well, the inventory is eventually going to show up, and then we're going to have too much demand, and we're not going to either be able to get the stores some of the other items they need, or we're going to have a really suboptimal transportation result, trying to get all that freight moved in a really unexpected capacity window. So this ability to go back and forth throughout the day, really responding to what's happening is really key. Now, the example we used here was an inbound shipment delay, but it could be a piece of automation equipment that went down. It could be a labor situation where, 12% of my pickers didn't show up today because the Super Bowl was yesterday. A common one, right? We know this happens all the time. We need to be able to be more intelligent about responding to those things when they happen, and not using this brute force method of just saying, the stores at the end of the schedule get nothing, or they get shorted in a really bad way in terms of the inventory that they don't get. We can be much more intelligent. Again, back to that notion of segmenting the demand. Some of it is must, but some of it is elective. And we've got to use that elective pool of inventory more intelligently to respond to these type of situations when they occur. Okay, now what we saw in all of those examples was this notion of bidirectional, and Bart used that word a few minutes ago as well, the bidirectional communication. Part of that is visibility, supply chain planning, just giving the operation a much more accurate and discrete picture of what's going to happen for them or to them based on the inventory that's actually going to be coming both inbound and outbound. But the more interesting piece is the ability to really change, to massage the distribution order to the store, the purchase order into the network based on what's happening. Why can we do this now? And why haven't we done this before? It's like, we didn't just come up with this idea here in the last couple of years. The answer to that is really the underlying technology. And, we've been on a journey over the course of literally the last decade. We started working on this in 2014 to rebuild all of our applications on, pick your favorite term, API first, microservice-based, component-based technology. Now, that's a lot of sort of technical mumbo jumbo, but why does it matter and why is it important? The most important thing about that is each aspect of all of these capabilities have full access to everything else on this diagram. So typically when you have supply chain applications overall, and particularly planning and execution applications connected, they're connected by a couple of integration points. Once or twice a day, some data goes back and forth. But when you have this unified API first-based architecture, anytime that planning wants to know something about what's happening in the operation or vice versa, they call the API. And frankly, the best way to think about this is really as a large single application. Now, from an architecture standpoint, of course, it's not that. It's not some big monolith that can't be updated very often or can't be extended or can't be modified. You get really the best of the both worlds here. I mean, because these things are independent, each one of these API, you can still do lots of updates to the transportation planning optimization engine during the course of the quarter. You can still write extensions, but also give the supply chain planning capabilities access to those API whenever they need them during the course of the day because of sub-second response time deployed in the cloud. In our case, Google Cloud Platform, which is where we run anything, but in cloud technology overall is really the more important point there. So that's it on the technology and how it allows us to and really enables us to go through some of those functional scenarios that Bart laid out and that I came behind to show, sort of the before and the after and what gets better from an operational standpoint. So Matt, with that, I think I will turn it back over to you to address any questions that we have coming in from the audience.
Okay, great. Thanks, Brian. I appreciate it. I know we're pretty short on time, but there are a few questions that I did want to get out there before we ended the session. So, and since Brian mentioned why Manhattan is doing this now, one question I have for you, Bart, is why is the alignment of supply chain planning and logistics important now?
Yeah, as I mentioned before, Matt, supply chains have changed, right? And again, 30 years ago, you were able to get away with planning something and then executing on it. In the middle, you had the manufacturing, but that's not the world we live in anymore. We now live in this highly dynamic world, plus things change all the time. So it's everything that happens have to happen in real time. I think even recently in Manhattan Momentum, I think CEO of Manhattan, Eddie Capel, he talked about the blue dot kind of generation, right? Where everyone is like, where is it? And I want it now, and everything needs to be able to change. And that's kind of the positioning we're finding ourselves in today. And so it's important that in order to accomplish that and be able to have what what a customer needs, but also to be able to do that in a very agile way. And I'll make one remark. We became a lot more agile in the beginning of COVID, and we got a lot of resilience, but I would often refer to it resilience at any cost. We're doing it, but it was costing us so much more in order to do it. To survive now, especially in today's economic environment, right, where the economic outlook isn't very good at the moment. So people don't want to expend more. They actually want to make sure that they do it very efficiently from a cost perspective as well. So in order to do that, you need to be able to do it real time, very dynamic, but you have to do it where you're really saving costs in the system, where you don't have to apply more people, where you're losing time, where you have to invest in more inventory, but doing it in a way where you can actually get the efficiency out of all the parts of the supply chain to still serve that customer very well, to be able to make the changes you need, but then do that, like I said, to do it in a much more profitable way. That's how you're going to get through this difficult time, and how people can build up their cash flow and, be able to make sure that they're in a good position to kind of bolster up that supply chain, not just today, but also for the next 3 to 5 years.
Okay, sure. So Bart, in your perspective, then, what do companies need to do to bring these two functions together?
Yeah, it's obviously looking at how do we connect the functions, right? So it's going back to people, process, and technology. Technology alone is not going to do it. But what's different now between people, process, technology, what we had in the past is we could tell the people to work together. We could align our processes more end to end, but then the systems didn't work together. So I think now we have a lot more the ability for the technology to be a unique and unified platform that helps us bring it all together. Secondly, it has the data that we can also share. So it's a great way to communicate and collaborate around. I think what's the biggest challenge today to do it is actually, on top of that technology, really organize yourself in a way that's a different way of thinking, that truly has different processes. Because it's a little bit like, any technology that you introduce, if you're introducing something new. I saw a video recently of a lady, she had a Tesla, right? But what she forgot to do is, like, I've got this new thing, but I have to change the way I deal with it. And actually, you see her show up on the video at a gas station trying to figure out, how do I fill this thing up? So it's not enough to just give people the tools, because they need to understand that in order to take the most out of the tools, you need to change the way you organize your processes as well. And I think that's a little bit of the challenge, but it also means that you have to pick a partner, a technology partner that can help you, one, by getting through that transition, and secondly, have a tool that's a lot easier to also use, something that's a lot more from a user experience and the UI, where you have the data at your fingertips, right? It's no longer, it's so hard to use these systems. It makes it a lot more easier than if you look at some of the older systems, where I remember 30 years back, I went to a Manugistics TMS class. It took me a week to train on it, and I came back, opened my computer, had no clue where to start. These systems are not just make it possible to connect everything, but they're also so intuitive, and where you really get through the intelligence behind it, all that information right at your fingertips.
Okay, great. So Brian, over to you. So in how are the three main platforms kept in sync when it comes to software updates? How does Manhattan make sure processes which span from planning to execution don't break?
Well, yeah, I think that really gets back to this question of what has the cloud done for us, and I think it's really allowed us to move away from this notion of versioned software. And as I mentioned in my prepared remarks, it's really the component or the APIs that are moving forward in time. And one of the commitments that we make really to ourselves and of course to our customers is that all of those components are going to move forward at the same rate. And the connectivity between them, whether it's the omni-channel stack talking to allocation within supply chain planning to understand where a product is in its life cycle, how far it should be sold through right now, and if it isn't, should I start to effectively prune those units of inventory by using online demand? It's kept in sync by essentially saying, from the point of view of each one of those API or components, It's one application, and it moves forward at the same rate. So that I think is one of the key capabilities. The second is the deployment itself, because it's all deployed within Google Cloud Platform. API to API connectivity is a handful of milliseconds, and so you have very low latency in terms of one set of capabilities that one might think of as very far away from the other in the supply chain, actually having immediate access to not only the data, but the business capabilities. Because the beautiful thing about an API-based ecosystem or architecture is not only can I get access to the current state of a particular order, or PO, or ASN, or shipment, I can actually invoke change. I can change its quantity, I can change its date, I can change its destination, I can change its route it's on. Having that type of flexibility is really the core to sort of getting to this next level of bidirectional collaboration.
So are there any microservices replicated between planning and execution? And if so, how is the underlying data kept in sync?
Well, we don't really need to replicate the data because of what I just covered there. So because we can go API to API, there's really no need to synchronize data the way there was in prior iterations of our applications or other applications. So when you had standalone siloed applications that needed their own repository, you really had no choice but to do big data synchronization processes once a day, or maybe you came up with more advanced real-time or quasi-real-time connectivity. But anybody who's worked in these systems knows that keeping data in sync between systems is one of the most painful and difficult things to do. By moving away from that and saying, okay, we're not going to have redundant copies of the same data. What we're going to do is allow any of those components or API to access anything else in the ecosystem real-time through an API call. You really, you move away from the need to replicate data at all. And you essentially just go get it when you need it. And that's really the philosophy that we've operated under as we started to make the migration to Manhattan Active Platform starting in 2014. But as is evident from the fact that it's now 2024, this is not a quick and easy process. I mean, this was an absolute complete redesign and rebuild, but we feel like, the upside and the unlocks are there by being able to offer this type of API to API connectivity across the entire portfolio of applications.
Okay, great. Bart, you had several examples illustrated optimizing towards a specific objective, at least like least costs, for example. How would the solutions know what the business objectives are, especially when the cost isn't the main driver?
Yeah, it's having the flexibility in the system to decide what is it that you're actually going for, right? Is it cost? Is it quality? Is it, for example, sustainability? Because we're going to start seeing that more, where maybe you don't want the lowest cost carrier, for example. You want to have the most sustainable carrier, especially if we're going to get in the future where we're going to get carbon taxes, et cetera. But I think it's having that flexibility, having more intelligent systems. And then a big part of that is, in order to make the right decisions, not only do you want better data within that particular silo of the function, but then able to share between the functions the data gives you really the insight to say, what is the best decision across the board? So when supply chain planning makes, especially at a strategic level, while you're doing sales and operations planning, you can share some of that data between the different systems and make, from the start, a much better strategic decision. That's all going to trickle down. So I think that's going to give a lot better information to the different systems and be able to take a lot more into consideration to make sure that you don't just optimize something in a very small corner. I often say that, hey, transportation is optimized, but we're sub-optimizing the supply chain, or we're sub-optimizing the industry. Again, more connections mean you can optimize at a much larger level, and you're increasing, obviously, the value across the enterprise at a multiple of what you would do if you do it at a much smaller scale.
Okay, thanks, brilliant. And one final question for you, Brian. Why hasn't this level of unification been done before?
Well, I think it's similar to what we talked about as we went through the material, and that is if you have standalone independent applications that can communicate only through traditional integration, you're really limited in terms of what you can do. Now, you can flow data between them, you can replicate data between them, you can hand off process control, and that's what's been done typically. What we want to move to is the ability for really any component in the overall ecosystem, be it planning or execution, to be invoked at any time and to take action at any time. And that's really only available if you are API first, and if you have a commitment to being API first throughout the entire stack. Because if portions of the portfolio don't conform to that design topology, then you start hitting these roadblocks. Now, theoretically, there's nothing about the cloud per se that mandates being in the cloud relative to being API first. But what you find is that from an overall deployment standpoint and keeping the software up to date as time goes on, thinking about doing that in a distributed deployed manner in data centers that other people operate in the hundreds or thousands just becomes sort of impractical and somewhat undoable. So that's where cloud as an enabling technology is an important one, because essentially by keeping this all within, in our example, the Manhattan operation, we keep those API up to date and performant and communicating. That said, they're all available to any other system in the ecosystem. So as our customers want to go plug that into ERP or their commerce engine or really anything, those API are as available to them to use as they are the sort of internal use between our API or between our components. So that's been one of the most rewarding, I think, processes for us or experiences for us in going down this path, is just how much more is possible by having all of these capabilities written and deployed in this way.
Great, fantastic. All right, well, I wanted to extend a sincere thank you to Brian Kinsella and Bart De Muynck for sharing your expertise and insights today. Thank you very much. And I also want to thank our audience for joining us today. I hope this webinar was informational and provided some really good insights into the potential of unifying supply chain plan future.